My name is Venkataraman. I'm speaking on behalf of Nandini Consultancy Center, a firm of chemical engineers and chemical business consultants based in Chennai and Singapore. Today we are going to discuss about selected chlorine-based projects which represent excellent investment opportunity as far as India's interests are concerned. Presently, India has installed a capacity of around 4.7 million tons of caustic soda per annum. Against this, India is producing roughly around 3.6 million tons of caustic soda per annum. India also producing around 3.15 million tons of chlorine per annum. Now the demand for caustic soda is steadily increasing in view of the highly relevant and multiple applications of caustic soda in variety of industries. While the demand for caustic soda is steadily increasing, the demand for chlorine is not increasing at the same pace. This creates problem because along with the caustic soda, chlorine is produced as a co-product. So when caustic soda demand increases, chlorine demand does not increase at the same rate, then it's difficult to expand or increase the capacity of the caustic soda. So this points out the need, or rather the urgent need, to build capacity for chlorine in the country. The problem with the chlorine is that chlorine is a toxic chemical which is difficult to transport over a long distance. Hydrochloric acid, which is made from chlorine, also has considerable quantity of the water content. So the freight cost for transport of the hydrochloric acid is also very high. Under the circumstances, the demand for chlorine and hydrochloric acid has to be found near the caustic soda producer. Either the caustic soda producer himself makes some products where chlorine and hydrochloric acid is used for captive consumption, or alternately find some units nearby, maybe promoted as the ancillary units, where chlorine can be well utilized. So this is the real issue that is facing the caustic chlorine industry that has been sorted out. The issue today is there are a number of chlorine and hydrochloric acid based projects which have potentially huge demand base in the country, but India is not producing. I'll give you just one case study. This is called Lysine Hcl. This is made from starch. From starch, by fermentation, you make L-lysine, which is an amino acid, and L-lysine is treated with hydrochloric acid to produce L-lysine Hcl. L-lysine Hcl is a very important component, or rather input, in the poultry feed as well as the pharmaceutical for humans. Because the human body does not generate L-lysine, animal body also does not generate L-lysine. So L-lysine has to be necessarily given to the animal, and for the pharmaceutical products treated for human from external source. Now, this Lysine Hcl finds application in the poultry feed, which is a very thrust area for growth. The country is not producing Lysine Hcl in spite of having good quantity of the starch, in spite of having good quantity of chlorine and hydrochloric acid in the country. So India is presently importing around 60 to 65,000 tons per annum of Lysine Hcl, and the demand is steadily increasing at 7 to 8% per annum. I find it extremely difficult to accept the situation that India is not producing Lysine Hcl in spite of such opportunities available. Now, apart from the Lysine Hcl, which I gave as a case study, I'm going to take three products today for discussions. One is polyvinyl chloride, which is otherwise called as Pvdc. Second product I'm going to take is chlorinated polyethylene, which is otherwise known as CPC. The third product I'm going to take is chlorinated chlorosulfonated polyethylene, is called the CESM. Now, all these three products have high level of relevance to the Indian industrial and economic growth pattern. There is no constraint in the availability of the raw material. The demand is steadily going up, and unfortunately, India is not producing. And unfortunately, it looks that no project for these products are in advanced stage of planning or implementation in the country at the present. Further, it appears that no research and development efforts have been taken in this country to perfect or fine-tune the technology for this product, for which the parameters, process parameters, are fairly well known. Now let us take the first product, polyvinylidene chloride, otherwise called as Pvdc. Now what is this polyvinylidene chloride? It is a white, color odorless powder. There are certain features with regard to the polyvinylidene chloride. It has high resistance to chemicals, including grease and oil. Other important property is its barrier properties for moisture and oxygen. So for moisture and oxygen, this has a barrier property which is being exploited heavily all over the world by the chemical packaging industry or the pharmaceutical packaging industry. The application areas for the PVDC are for packaging of food, consumer products, confectionery, dairy products, fish, meat, etc. In other words, all the products with high flavor and aroma and moisture, which need for a packaging material, which have barrier properties to these moisture and flavor that is required. So that in this case, for packaging purposes, PVDC has become an essential input to the packaging sector. Now this is being used all over the world and the demand is steadily going up right now. Other important area of application is the pharmaceutical sector, where it is used for blister packaging to package the medicines which are sensitive to moisture, a very important property. And third is, it is also used as anti-corrosive coating formulations. So you will see in all these three applications, mainly as a packaging for food confectionery industry as well as the pharmaceutical, all are highly growth-oriented industry. With the packaging technology improving it steadily, consumer expectation becoming bigger every day, and the need to be ecologically friendly in packaging and to avoid spoilage of the products, packaging has become very vital. And for it, PVDC, with its barrier properties, is becoming one of the very, very important areas of that is contributing demands of PVDC. Now, what is the major user sector? As I told you, it is food and package, confectionery and beverage, number one. Number two, pharmaceutical. Number three, cosmetics and others like coating. Internationally, around 45% of these PVDC is used for packaging the food and beverage. Around 25% of the PVDC is used for packaging pharmaceutical products, medicines. Third, 30% is used for packaging cosmetic and other applications that are much needed. Now, what is the Indian scenario? India is presently importing around 10,000 tons of PVDC per year. There is no production of PVDC in India. No project for PVDC appears to be in the advanced stage of planning or implementation in the country. And the Indian demand for the PVDC, which finds very vital application in the packaging of food, confectionery, and pharmaceutical, which are all thrust areas for growth. The demand is steadily increasing at 7% per year in the last few years. This growth in demand is likely to be sustained. So we find a situation where India is importing 10,000 tons. There's no production in India. The demand is steadily going up. This points to the need for creating capacity for PVDC as urgently and as early as possible. Now, what is the global scenario for PVDC? The global demand for PVDC is somewhere around 0.3 million tons per annum. Otherwise, it is around 3 lakh tons per annum. The global demand is steadily increasing at 4 to 5% per year. And this product has become very popular all over the world for packaging. Now, who are all the producers? One of the biggest producers of this PVDC is the Solvay. Solvay is a joint venture between Solvay and BASF. Solvay has production facilities in France and Germany. Other important producer is SK Global Chemicals in USA. Then also we have Asahi Kasei in Japan, and a few producers in Japan and a number of producers in China. We are not making in India. Now, what is the process for this PVDC? See, PVDC is produced using ethylene dichloride as a starting material. The ethylene dichloride is chlorinated to form 1,1,2-trichloroethane. Then this trichloroethane, which is produced in the first stage, it is now dehydrochlorinated in the second stage by treating with lime or caustic soda when you get vinylidene chloride. Then this vinylidene chloride is polymerized to produce polyvinylidene chloride, that is the PVDC. That is the process. So basically, raw materials are ethylene dichloride, chlorine, and caustic soda. We have enough chlorine, we have enough caustic soda. With regard to the ethylene dichloride, it is generally produced by the PVC manufacturers. They start from ethylene, produce ethylene dichloride, then convert it into vinyl chloride monomer VCM, and then it is polymerized to produce PVC. Now, a number of PVC producers in India make ethylene dichloride. Some of them are also importing ethylene dichloride due to short supply of ethylene in the country. Now, ethylene dichloride is available internationally adequately. The most PVC producers have. India is already importing ethylene dichloride in substantial quantity. There is no particularly constraint in the availability of ethylene dichloride. So we got chlorine available, we got caustic soda available, we got ethylene dichloride available. Now, this is the ideal situation. Now, what is the quantity that is required? For 1 ton of Pvdc, requirement of ethylene dichloride is roughly around 1.26 ton. That of chlorine is around 0.9 ton. For caustic soda, it's around 0.46 ton. The price in the international market is right now ruling at around $3.2 per kilogram. So looking at every point of view, availability of the raw material, demand in India, growth potential in demand, relevance of the product to the industrial and economic growth pattern in the country, and importance of the packaging area that is becoming increasingly important and vital, PVDC is an excellent product that India needs to create capacity. Need to create capacity not only to meet today's need, the emerging need, and also we can comfortably target the global market because we are a large producer of caustic soda and chlorine. There is no doubt about this. This is a very, very vital project. Now we will move on to next product called chlorinated polyethylene. It is called CPE. Now, what is chlorinated polyethylene? This is a thermoplastic polymer. It is a white powder. Now, there are certain features of this particular product. One is it has high level of resistance to heat, oxidation, and ozone. It has flame retardant properties, and it has oil resistance. Now, when you produce this chlorinated polyethylene, the chlorine content in the polyethylene can be varied depending on the end user application. So producers make chlorinated polyethylene in various grades in the chlorine content ranging from 15% to 73%. At different chlorine content, has got different end use applications or particular specific application required by the individual consumer can be made available by the producer. And now, what is the application? The most important application of chlorinated polyethylene, it is used as an impact modifier. Now, what is impact modifier? Impact modifier improves the flexibility of the product in which it is used. It reduces the inherent brittleness of the product and also increase the impact strength. It's a very, very vital property. Now, this chlorinated polyethylene can be used alone, all by itself, or it can be blended with PVC or polyethylene or polypropylene or polystyrene or ABS or polyurethane. So what happens is when you are going to blend it with PVC or polyethylene or polypropylene or other polymers, the properties of this blended material far improves because of the impact resistance properties of this chlorinated polyethylene. So it is considered very vitally important. So the consumers are going to be largely the PVC producers or the PVC compound manufacturers who can buy the product from PVC manufacturers and make it, or the PVC manufacturers who also make the end product based on PVC. They are going to be a major consumer, apart from other polymer producers like polyethylene, like polypropylene and all. The people who make polypropylene compound, they also can be the biggest consumer for this particular product. Now, which are the important user sector? Automotive, number one, because of the impact resistant properties, and then wires and cable, then adhesives, hose pipes, PVC piping, etc., etc. Variety of application areas are there. Now all these application areas have high level of application, high level of relevance to the growth pattern. Now, what is the Indian demand? Indian demand is roughly around 10,000 tons per annum as of today, and we are not producing a kilogram of this product. Indian requirement is entirely met by import. As I look at the past records, I find the demand has been steadily increasing during the last few years at 6 to 7% per annum. This trend is likely to continue, and this growth trend looks like it even further go up more because of this important increasing application of polymers, and particularly people looking for the impact modifier properties of this chlorinated polyethylene. So what is a global scenario? If we look at the global scenario, the global demand is around 0.45 million tons per annum, 4.5 lakhs tons per annum. Now, there are a number of producers. Dow Chemical Company is a major producer. Then Weifang Exim Chemical Company in China is another important producer. There are 7 or 8 producers in China, another country. So there is no issue. There are a lot of people are making this particular product. Now, how it is made? This chlorinated polyethylene is manufactured by simply chlorinating high-density polyethylene. High-density polyethylene resin is being chlorinated using chlorine to produce chlorinated polyethylene. Now, what is the raw material consumption? For 1 ton of chlorinated polyethylene, the requirement of polyethylene is 0.75 to around 0.75 ton, and chlorine is around 0.25 to 0.3 tons for 1 ton of chlorinated polyethylene. The price is now around $1.45 US per kilogram. Now, this is again a very excellent product because it has impact resistant properties, very, very vital. Internationally, around 45% of the application for this chlorinated polyethylene goes for its particular properties as impact resistance. And it has such as heat resistance, oxidation resistance, ozone resistance. There are very vital areas. So they find application in variety of areas like wire, cable, adhesives, hose pipe, PVC, and all this highly relevant area. India need to create capacity. Just as the case of Pvdc, you need to create capacity not only to meet today's India's demand, projected India demand in the coming year, which is bound to happen very steeply. Demand is likely to go up. International demand can be met because all the nearby countries, the product is not being made. It's likely to be huge demand. So the export potentials are also very high. And raw material is only chlorine. We have got plenty. Produce polyethylene. We are producing in the country. There is no constraint. So what is holding us? There is nothing holding us. We have to move on. We have to identify this project and seize the opportunity. Now we'll go to the third product. It's called chlorosulfonated polyethylene. It is called CESM. Now what is this? Chlorosulfonated polyethylene is a special rubber. It is a white, colorless flakes. Now what are the features of this particular product? This typical polymer, chlorosulfonated polyethylene, contains around 25 to 40% of chlorine and 1% of sulfur. Now, most important properties of this chlorosulfonated polyethylene is working temperature range is from minus 20 degrees centigrade to plus 125 degrees centigrade. It's a huge working temperature range is there. So it can be used at minus 25 degrees centigrade, 20 degrees centigrade, or up to plus 125 degrees centigrade, which is considered a very, very important property of this particular product. Then it has excellent weathering resistance. It has got ozone resistance, low gas permeability, and also chemical resistance is very, very good. Now, where are it being used? User sector, it is used as anti-corrosive coatings for plant and equipment. Normally, it is coated inside the equipment or outside the equipment, wherever the anti-corrosive coatings are required. Because the fact that it can stay comfortable at various temperature range is particularly very, very important while using it as an anti-corrosive coating for the plant and equipment. Other application is the wires and cable, shoes, hose. They're waterproof around the roofs. That's again a very, very because it has excellent weather resistant properties. Now, what is the user sector? Automotive parts, electric parts, industrial articles, coatings, polymer master batches, etc. Internationally, around 23% of the chlorosulfonated polyethylene used for automotive parts. Around electric parts, around 20% is used. Industrial articles, around 36% is used. And remaining coatings, etc., around 21% is used. All these are highly relevant areas of application. So, what is the Indian demand? Indian demand is just now around 1,500 tons per annum, 1500, and not produced in India. Demand is likely to go up steadily. and growth rate is even by conservative estimate, it should be well over 7% per year. What is the global demand? Global demand is roughly around 60,000 tons per annum. You may be surprised that such an important product, the global demand is only around 60,000 tons per annum. Why it not more? The reason is this chlorosulfonated polyethylene is comparatively recently introduced product. Application developments are still taking place. New areas of applications are emerging, and consumers are switching over to use chlorosulfonated polyethylene. In all these kind of products, with such versatile application, the demand will go up only along with the supply. Unless you have enough supply, people cannot consume it. So the problem with this chlorosulfonated polyethylene, supply is not good enough. That means demand remains constrained. If supply goes up, automatically demand will increase because the highly relevant areas of application. Now, who is the important global producer? Toso Corporation, Japan, is a pioneer as far as the chlorosulfonated polyethylene is concerned. This company is now expanding the capacity of the plant, and the company is speaking very highly about the prospect for this plant of this product in the coming years all over the world. And the company is very, very confident about this and is very keen to expand the capacity further to meet the emerging and forthcoming demand for this product. Now, what is the process? Now, it is produced by chlorination and chlorosulfonation of polyethylene. That is, it is produced by reacting polyethylene, which can be LDPE or HDPE, with chlorine and sulfur dioxide. So, as I said earlier, this contains around 25 to 40% chlorine and 1% sulfur. And based on the chlorine content and the molecular weight, different grades are produced by the producers to meet the specific requirement of the consumers. Now, what is the raw material requirement? The chlorine requirement is roughly around 0.3 ton. So all these three products, polyvinyl chloride, chlorinated polyethylene, and chlorosulfonated polyethylene, CSM, have what is in common? Chlorine utilization is in common. Another important factor that we have to do is this petrochemical industry, Pvdc is made from ethylene dichloride. That is one important factor, which I said has to be imported or taken from Pvdc people. And other two products, chlorinated polyethylene and chlorosulfonated polyethylene, are both relevant both to the chlorine manufacturers as well as the manufacturers of polyethylene, LDPE and HDPE. Even the LDPE and HDPE producers can use this, can start producing this product because they have got enough polyethylene available with them. And if there is a company which is producing polyethylene along with the caustic soda plant, they have got a win-win situation because they have got LDPE, HDPE available with them. They also have chlorine available with them. So it's a win-win situation for both. My objective in bringing these products is there are a number of similar chlorine-based products which have emerging applications. Few products are being developed where it appears that India looks totally uninvolved as far as these products are concerned. This is surprising. Problem with all this called implementation of these projects is now demand is good, demand is going up, there is no dispute over it. Consumers want this product, but where is the technology? Necessarily, we go abroad for taking technology, even for small countries like Taiwan, Israel, or Korea, and all this, without taking steps to develop technology. That is the basic problem in several of the products, including this product. As I said earlier in one of my meetings, India is going through a technology crisis. It is more than reflected by this product. The moment I am going to tell an entrepreneur that produce a Pvdc plant, or produce a chlorosulfonated plant, or chlorinated polyethylene plant, he is not going to dispute my figures with regard to demand supply. He will ask me, where am I going to get the technology from? Where will you get the technology from? You can't go to international companies because they say your capacity of plant is very small. Or these are increasingly vital products. Why should the international companies share the technology with you and create a competitor for them? There may not be licenses or technology readily available unless a product like urea or diammonium phosphate. So what is the problem? You have to develop a technology. What is the constraint to develop? There is absolutely no constraint in developing technology because process parameters are fairly well known. All that is required is only fine-tuning the product, which is the task that the research and development departments have to take place, companies R&D personnel have to take place. Here today, what is happening here? I'm surprised that such important product like Pvdc or chlorosulfonated polyethylene or chlorinated polyethylene, when I sought whether technology is available from many of these laboratories, most of the laboratories said they have not worked on it. Why they have not worked on it? The issue is the R&D personnel need to be aware of the market opportunities. When they are aware of the market opportunities, then they have to focus their attention in developing technology for the product and give it to the end user, give it to the company. Probably government of India also has to play a role where they have to identify all these particular products where demand is good, demand is growing, where India does not have technology, create some systems, create some incentive so that Indian research and development personnel will start working on it on a targeted area. This is a case study, this chlorinated polyethylene, this chlorosulfonated polyethylene, Pvdc, enormous opportunities waiting in the country. We need to move on. Probably a period of 6 to 7 months, somebody can develop the technology here, put up the facilities. If this is done, the objective of my lecture is well fulfilled. Thank you very much.